Working in drafty rooms caused by an air conditioning system makes us feel uncomfortable. Unlike birds, we have no feathers, and so to us, drafty air movements are unpleasant and disturbing. The construction of the new Franz Josef Strauss Airport outside Munich laid the foundation for continued success of a whole region. Foresight and innovation have made one of the most modern airports a traffic hub located in the center of Europe with more than 23 million passengers per year. The airport employs more than 16,000 people in more than 300 buildings, covering an area of more than 3,700 acres. High demand and emphasis on economical operation and comfort is placed in the state-of-the-art buildings for administration, logistics and engineering. Responsibilities for passengers, employees, the environment and the search for innovative solutions have led Munich Airport to use the Bauer optimizing system as their HVAC control system. The glass facades used in modern buildings represent a unique challenge for climate control systems. The constant supply of fresh air to provide an adequate amount of oxygen needs to be balanced with evenly distributed, comfortable temperature. To demonstrate the airflow patterns during conventional operation of the HVAC system, we introduce artificial fog. Using the current HVAC technology, high supply air volume and strong air currents are necessary to achieve the required mixing of supply air and the air in the room. The HVAC system hardware has to be sized accordingly. High energy consumption is necessary to generate these strong air currents, which have the negative side effect of generating undesirable drafts and directed airflow patterns. Especially uncomfortable are drafts caused by cooling air cascading down large glass facades. Such cascading cooling air is very visible along this large glass facade. This close-up impressively shows how the room air cools as it comes in contact with the cold glass surface. The artificial fog clearly shows the resulting downward draft. In the gallery, the complete absence of artificial fog and thus the absence of air mixing adjacent to the directed airflow is obvious. What you see is the root cause for uncomfortable temperature differentials. In the sitting area, on the other side, you can observe another manifestation of drafts. The placement of the supply and return air vents results in strong upward and downward directed airflow patterns. This downward directed air current has an especially negative effect on the room comfort in the sitting area during the conventional operation of this HVAC system. When running the Bauer optimizing system, the upward and downward air current patterns change completely. A short time after switching over to the Bauer system, you can observe how the artificial fog mixes with ever-changing airflow direction slowly and homogeneously throughout the whole hall. It is especially visible how the artificial fog evenly distributes around the sitting area. This further demonstrates that even furniture no longer hinders the optimal mixing of the supply air with the room air. The light beam directed at the wall of artificial fog shows the air flowing in all directions from the floor all the way to the domed roof. The artificial fog now reaches every corner of the room. Dead zones no longer exist. The fog expands approximately 150 feet before it slowly approaches the glass facades. The fog continues to spread evenly without noticeable change in airflow patterns. When using the Bauer system, the type and location of the supply and return air vents no longer have an influence on the air distribution and mixing in the room. The normally expected temperature differential between the ceiling and floor areas is drastically reduced. The virtual elimination of the effect of cooling air cascading down the glass facades is another clear indication of the even temperature distribution. Defying commonly expected thermal behavior, air now moves both up and down. Temperature islands no longer exist. Conventional HVAC systems simply cannot accomplish this effect. Additionally, service and maintenance costs are reduced significantly, and the life expectancy of your HVAC hardware is increased. The construction cost of a new HVAC system is reduced significantly, as the Bauer optimizing system requires fewer hardware components and smaller design proportions. In summary, the Bauer optimizing system optimally delivers the dual goals of economy and comfort. In a conventional system, these two goals are mutually exclusive. Out of these complementary goals, we developed our company motto: the more you save, the better your room feels.